Hello guys, let's go to number 3, which is the enthalpy change of reaction, but this time it's gonna be the reverse. The formula will be like this: a standard heat of formation, but no more the average band dissociation energies. Okay, we have like this delta HF, okay, of the reaction standard with the circle at the top. Okay, is equals to the summation of the enthalpy change of the formation of the reactants HFR standard. Okay. Minus, this is the, this is the reactant product na siya, baliban siya. Okay? Imong timanan guys, the reverse ang enthalpy change of the formation of the reaction. Not referring to the, average band dissociation energies. Okay? Like this. Minus the enthalpy change of the formation of the reactant standard. If you see a circle at the top that is standard, this enthalpy change of the formation of the reaction or the reactants and the products are measured at 25 degrees Celsius. Okay? So you can find this in the table, in the books, okay? In physics, in chemistry, organic chemistry, quantitative chemistry, qualitative chemistry, or you can say biochemistry, biochemical engineering, or the Paris Chemical Engineer's Handbook. Okay? Something like that. Especially if the values of this enthalpy change of the formation of the products and reactants are not being shown in the question, not given. So you will be the one to look at it individually. If you see a circle at the top, meaning standard. Okay? You get the point. If there's no circle here, do not try to look. So it is obviously mentioned in the problem. Okay? If there's no circle here, okay, at the top, because that's standard. Okay, the question here: find the delta H of the formation of the reaction of this 4 moles of ammonia. Okay, 4 moles of ammonia plus 5 moles of oxygen. Balance already the chemical equation. We are very, very lucky. We don't have to make our own chemical equations. Okay. 4 moles of nitrous oxide plus 6 moles of water. But again, don't believe immediately because sometimes the question is showing also the incorrect chemical equation, not balanced properly, and then it tricks you out talaga. When you proceed to compute, then you will be wrong. So investigate first if it is really true. 4 nitrogen, okay, balance. Ay, nakakaloka. Ano ba yan? Okay, 12 hydrogen, oxygen, 16 oxygen. Okay, balance siya. Okay, ganon. So, and the delta H of the formation of the reaction is equals to the summation of the products, which is the enthalpy change of the formation of NO. Take note, NO, then times the number of moles, which is 4. Okay, times 4. So, it is expected that the value in the tables are kilojoules per mole. Right? Because we multiply this with the mole. But take note, if there's no mole in the denominator that's already hit, and don't put the moles here in the equation. Things like that. Okay? Because that's already simplified. You get the point, mga palangga. So, ganon. So, plus. Okay, plus delta heat of formation, enthalpy change of formation of water. Okay, enthalpy change of formation of the water times 6 moles. Okay, and then you need to bracket this whole thing minus the enthalpy change of the formation of the reactants. So, start with ammonia. 4 times delta change, enthalpy change of the formation of ammonia, okay, like that, plus 5 moles times the delta change of the formation of the oxygen gas. Okay, ganon. So, yun yung guys, this is enthalpy change of the reaction, and here enthalpy change of the formation of the reactant and product, not reaction. But still, enthalpy change of formation. Okay? Enthalpy change of formation of water times 5. Now, since you are not given with these values of the enthalpy change of the formation of the reactants and products, and you go to the table at 25 degrees Celsius. Okay. Based sa akong pananaliksik chart, based on my research, the standard heat of formation, actually the enthalpy change of formation or the standard heat of formation is just the same, ha? Okay? The enthalpy change of formation standard is equals to the heat of formation standard, like that. Okay, so we have delta HFNO, we have 90.3. Oh, ganun. So, 90.3 mga palangga. Kilojoules ra gyud siya. Okay, kilojoules, so no need to multiply this with the mole. Okay? But, you get the point, because already a heat, kilojoules naman siya, so no need to put the mole. You get the point? Or else it will become kilojoules mole. So it's not the unit of the molar enthalpy. There's no unit kilojoules mole man siya sa kilid. So no need to. Ilan ako papasa for the purpose, I will never erase for the purpose of discussion only. But actually you will never multiply with mole because the given in the table has no mole in the denominator. So there's no use for the number of moles here. Okay, but this is really standard. Okay? Like that. So, plus. That's why you need to really write everything so that you will know what is cancelled, what is not. And if you memorize like this only with the number of moles and if you times and you will never carry the units, you will become wrong also. So you get the difference. Okay, because if you try to memorize this formula like this na times and good siya, we need to multiply every time with moles and then the enthalpy of formation in the table has no moles in it, dahil hanga. Because it will never be cancelled the mole, it will become kilojoules mole, and it's not the unit already of heat energy or the enthalpy change of reaction. Things like that, you need to be particular in the unit. Okay? Something like that. So, wala siya netabo. So, 5, sa ina na siya. Then sa water, we have negative 29, ato for 1.8, 2 for 1.8. Okay, kilojoules. Okay, minus ammonia. I don't carry the moles because it's no longer used in this particular problem. So the enthalpy change of formation of ammonia is, it's here also, negative 459 kilojoules. And then plus the enthalpy change of formation of water, we have, no, oxygen gas sorry. Oxygen gas. Tapos ito sa water. So oxygen gas, okay, put this in your brain cells. If you talk about oxygen gas, that's always 0 kilojoules. Only for oxygen gas, it will become 0, or I think so for elemental, solo element, something like that, okay? 0 kilojoules. Okay, like that. So do the math, okay? Like that, pila man siya mga palangga. It's not 0 all the time, but sure ko sa oxygen, but just look to the table to make it sure. But by theory, oxygen really is 0. Okay? That's what I mean. Okay? To make it safe. Okay? Like that. So, meron siya mga palangga, no? So, 90.3 minus 2 for 1.8, and then it's gonna be, oh my gosh, plus 459. So 307.5 is our enthalpy change of the formation of the reaction. It's positive. 307.5 enthalpy change of the formation of the reaction, and then also standard heat of formation of the reaction. Like this, positive, meaning to say the heat is being absorbed or added by the system. Meaning to say the environment is cold. Okay, this is not exothermic. Exothermic because the environment is hot. Okay, because the heat is being released. Okay, you get the point. So this is endothermic reaction, and then non-spontaneous, and then reversible chemical reaction. Okay, meaning say if you try to have this equation, it will goes back to its original reactant, same ammonia plus oxygen, because this is reversible man siya. Okay. You get the point? Ganon. So, same siya, diba? Compare sa enthalpy change of combustion and enthalpy change of formation. Don't be confused with the enthalpy change of formation with average band dissociation energies because the table's having band, chuba, chu, chu. But in here, nothing. See? The given is just like this. Okay, nothing. So you can really compare. You will also have the comparative analysis, how to be applied. Okay, the applicability matters a lot. Okay, so that you will not become wrong in your answers. Okay? Dito point ko na palangga. Okay. And take note, the little circle at the top, that is standard. Huh? Standard heat of formation of the reaction. Standard heat of formation of the reactant. Okay, enthalpy change of the formation of the reactant. Enthalpy change in formation of the product. Standard, if there's a zero at the top. Ha? Muna siya yung mga standard, chuba, chuchu. Okay, you get the point mga palangga? Any questions so far? Thank you so much for listening. If you like this video, you can comment, you can share, and you can even, whatever, whatever you're trying to do in this particular vlog. And then you can subscribe to the channel if you want, if you like, and then you can click notification bell for some news updates if I am a singer, eternal voice. Okay? Any questions so far? So actually, guys, the Hess law, the constante observation is more difficult compared to these three topics, really. Okay? And the little bit easier is the stoichiometric on enthalpy change of reaction is very easy because you need to get the number of moles only and then play around the calculation in the what we call dimension analysis conversion, and then you can apply. Compared to this, it's very more complicated. Okay? Ganon. Okay, then I'll be able to discuss also tomorrow with the reaction mechanism. Okay, how to predict the rate loss like that. Okay, what's gonna be happening if we try to add more water volume of particular gas? What will happen? It will shift to the left, it will shift to the right, it remains constant. What will happen to the shifting of your system of equilibrium, something like that. It's gonna be the Le-Chatelier's principle, okay, discovered in 1901, 19th century by Mr. Le-Chatelier. He said that when a system of equilibrium is added, then it will reduce the stress, something like that. Okay, or let's say generally, whenever a system of equilibrium is applied, then it will be directed to the direction so as to reduce the stress, something like that. Okay? Ganun siya. Okay, mga palangga. Okay? Thank you so much. Bye-bye. God bless everybody. Kaloka.